Okay, number 6. Given the graph of the derivative of the function r of x, answer the following questions. So this is bolded and underlined because this is pretty difficult for people to wrap their mind around, including myself. It happens to me a lot where I read the problems and I'm like, right, this is the original and this is a really easy problem, but it's not. This is a graph of the derivative of r of x. I don't have the function r of x, I only have this graph of its derivative. So looking at the derivative of r of x, I need to figure out what's happening for r of x. So at what values of x is r of x not increasing or decreasing and has a slope of 0? Okay, at what values of x is r of x not increasing or decreasing? So this is my derivative. This is telling me about slopes. So I'm going to look right here and right here because my slopes are 0 at that point. So that's like negative, and it's not exactly on any line, so I'm just going to go, let's say, negative 2.2, and then the other one looks like it's at 2.2. And then this is where all that training we've just done comes in handy. But if I'm being totally honest, I always forget. So what I do is I draw myself a little maximum over here, and then I remember that for a maximum on an original function, the slopes go from positive to negative. So then I'll look on this graph and looks like positive to negative. So the slopes are positive here, or the y values of the derivative are positive before 2.2 and then they're negative afterward. So I think 2.2 is a maximum. And then for negative 2.2, this one has negative slopes. So I'll imagine drawing something with negative slope, and then a slope of 0, and then afterwards a positive slope. To me, that looks like a minimum. Okay, so part B, for what values of x is r of x decreasing? So decreasing means that the slopes are negative. Let's get rid of all this junk. So I'm looking to see where it's decreasing. This is a graph of the slopes. Negative, we want negative y values. Okay, come on. So that seems like it's happening on the outside. So negative infinity to negative 2.2, and then furthermore from 2.2 onward. Part C, for what values of x is r of x increasing? And so that's where slopes are positive. So I've got this graph of slopes that's going to be in the middle from negative 2.2 to 2.2. Oh, this is a great question. At what value of x is r of x increasing most rapidly? So I'm looking to see where the slope is highest, the largest slope. So this graph here, this is a slope of, not a slope, this is a graph of slopes or a graph of derivative. So the highest slope is happening at 0, and it's like a slope of 5, a positive 5. So we think this is happening at 0, and what is the slope at that point? It's 5, because when I plug in x equals 0, so if I plug in x equals 0, I get a y value of 5. Those y values correspond to the slopes of the original. So I've got a slope of 5. Cool. At what values of x is r of x concave down and concave up? Okay, concave down. So concavity, I need to think about the second derivative. I've only got the first derivative, so I need to look at slopes. So let's erase so we've got a clean graph. So instead of looking at the y values, now I'm thinking of slopes. So all of these slopes are positive until here. So if the slope of the derivative is positive, that tells me this is concave up. Or you could also think of it as the second derivative is positive, which then tells you that it's concave up. So all of these derivatives are negative. This is concave down. So let's see. Concave up before 0. So negative infinity to 0. And then it's concave down from 0 to infinity. So where does r of x have an inflection point? That's going to be 0 because it changes from concave down to concave up. This is really, really difficult stuff. Like this, I feel like this is very mind-bending. So please ask questions on the discussion board. There's just one more problem. We're almost done. So I'll stop and we'll do that one.